So this is my presentation on page fault handling mechanism. Here we'll understand memory management in operating systems. So this is the introduction. Here we'll see the topics that we are going to study in this PPT. We'll study about page fault handling mechanism in virtual memory systems, and a brief overview of memory management. So this is a diagram for paging mechanism. This has two types of addresses, logical address and physical address. So this diagram seems a bit complicated right now, but further we'll study what actually these addresses mean and why is the physical address used when logical address was already available. So now we'll start with paging mechanism. What exactly is paging mechanism? Before studying page fault, we need to know what is paging mechanism. So in paging mechanism, memory is divided into fixed size blocks. There are two kinds of memories. One is the virtual one and the other is the physical memory. So virtual memory is in the form of pages and physical memory is in the form of frames. So this allows non-contiguous memory allocation and easier memory management. CPU can directly access memory from the from the physical memory. So when a program runs, its pages are loaded into available frames, hence the physical memory, because the CPU can directly access it. So why these kind of memories? Two kinds of memories. So virtual memory versus main memory. Let's discuss what these memory mean. Virtual memory is a logical abstraction of memory managed by OS. It is used when main memory is insufficient. Main memory is the physical memory installed in the system. This is directly accessed by the CPU and is used for running programs. So here virtual memory comes into picture only when the main memory is insufficient. The main memory is directly accessed by the CPU, but if there's no more space left, then we come to the virtual memory. It has sufficient space to be utilized. Now page fault. Why it happens and how it happens. It happens when a program is accessed but a page is not in main memory. It is managed by the operating system, common in virtual memory systems. What are the benefits of virtual memory? Process isolation, efficient multitasking, memory abstraction, but mainly it comes into picture when the physical memory doesn't have enough space. Memory management. So now, how the memory is managed. What happens when there's no more space left in the physical memory? So there are various it is divided into number of steps. When a page is not in RAM, page fault occurs. The OS uses page tables to track which pages are in memory and which are not. Then, what happens when a page fault occurs? OS checks if the memory access is valid, finds a free frame in RAM, may use a page replacement algorithm if RAM is full, loads the missing page from secondary storage into RAM, updates the page table, resumes the execution of the process. So we find a free frame in the RAM. The RAM is it may use a page replacement algorithm. So now since we are not having enough space in the physical memory, we go to find space in the virtual memory. Goal. Efficient memory management ensures smooth handling of page faults with minimal performance impact. Efficient handling ensures smooth multitasking. There are two kinds of page faults. In a minor page fault, page is in memory but not mapped, and in a major page fault, page is on disk, must be loaded. Causes of page faults. There are many causes, but here we'll study about a few. Accessing a page for the first time, page has been swapped out to disk, invalid memory access. Now, how do we handle page faults? Let's discuss a few steps. First, CPU taps to OS. Page fault interrupt. OS checks if access is valid, finds a free frame, loads page from disk to memory, updates page table, and restarts the instruction. Page replacement algorithms. There are different kinds of algorithms. First is first in and first out, least recently used, theoretical best. I would like to name the least recently used LRU and theoretical best optimal. Again, this is an example of FIFO algorithm. So let's move on to the other topic. Performance impact. High page fault rate leads to low performance. Thrashing, excessive paging due to low memory. So this is a term basically when there's excessive paging due to very low memory in the RAM. Optimization strategies. What do we do to decrease the chances of thrashing? Increase RAM so that there can be more memory storage, and so we have to do less paging. In tune working, set size, use better page replacement algorithms. So here, this is a brief on virtual memory. Since virtual memory is a big part of page fault handling mechanism, so there are two kinds of addresses as we discussed earlier. This is like a summary of the virtual memory. CPU uses virtual addresses, main memory uses physical addresses. Hardware translates virtual addresses to physical addresses via an operating system. And this is basically a table. The table states the two kinds of memories, virtual and physical. The two kinds of addresses also, virtual address and physical address. Optimization techniques to reduce page faults. Increase physical memory, use better page replacement algorithms, reduce multitasking, tune OS parameters. Hardware and OS role in page fault. CPU detects the fault and signals the OS via trap, and then the OS role in page fault. OS determines if the access is valid and handles the page fault appropriately. So finally, the conclusion. Page fault handling mechanism is essential for memory management since there are it has low memory, the RAM has low memory, then there are chances of thrashing. So we need to manage the memory accordingly. Page faults are normal in virtual memory. Too many faults can lead to performance drop. That is thrashing, as we discussed earlier. Requires smart OS policies, balances performance with memory efficiency. These are some of the references that you can use for the given topic. Thank you for your time.